Torque is the measurement we use to ensure that our fasteners and tools are meeting our quality requirements. However, we can never control torque until we begin measuring the process. The founders of quality control and statistical process control understood the importance of careful measurements. Quality experts such as Juran and Deming believe that it isn't good enough to guess what the problems are, or whether there even are problems. You have to know. Deming expressed his belief best when he said, "In God we trust. All others must use data." By applying the principles of statistical process control, we can ensure that the torque applied to a fastener falls within an acceptable range. This is the basis of the Torque Integrity Assurance Program, or TIAP. This program presents the following topics: an overview of the Torque Integrity Assurance Program, measuring torque, power tool certification, torque specification, standardization, and roles and responsibilities. The primary objective of the Torque Integrity Assurance Program is to establish a benchmark for torque integrity in all vehicles and to maintain and improve performance through statistical process control. Vehicle operations and product development each have an important role in carrying out this objective. We will examine vehicle operations and product development's responsibilities in greater detail later in this program. For now, let's review some of the concepts related to torque and its measurement. Torque is the force that rotates the fastener. Clamp load or tension is the result of torque. It is the force that holds parts together. Adequate clamp load is the primary objective when installing a fastener. However, clamp load cannot be measured outside the laboratory. Therefore, we measure torque to estimate the clamp load present in a joint. The relationship between clamp load and torque will be affected by the components in the process. We will discuss this later. There are three distinct types of measurements: dynamic torque, residual torque, and minimum torque. Dynamic torque is the measurement of torque during the securing process. It is measurable only while the fastener is rotating. The maximum or peak value is only obtained during the tightening cycle. Torque specifications, therefore, are given as dynamic torque values in Newton meters, since they define how the process must be performed. Residual torque is the measure of torque on a fastener already secured. It is the value measured with the torque wrench as soon as the fastener begins to rotate again in the tightening direction. Reproducibility and repeatability studies have shown that significant measurement errors can occur. Therefore, residual torque is only used to monitor the process and should not be used to assess the capability. Residual inspection limits are the measured outcome of the process. Let's examine the factors that can produce variation in torque measurement. A graph of torque over time shows that the residual torque reading can differ from the dynamic reading. This is due to temporary relaxation, component yielding, interaction between fasteners, and changes in friction characteristics. Temporary relaxation occurs when a fastener is secured and the components are not quite flat. Component yielding occurs when the clamp load created by the fastener exceeds the compressive strengths of the parts in the joint. Deformation of the component results after the fastener is secured. Interaction between sequentially secured fasteners will cause residual torque to change in the first secured fastener. In these situations, a multi-spindle tool is preferred. Changes in friction can also result in variation between residual and dynamic torque measurement. Residual torque can be higher because it may take more torque to restart rotation than it does to maintain rotation. We know variation in torque occurs. Therefore, it is necessary to establish the minimum acceptable torque for each joint. Minimum torque is the lowest acceptable torque value for a specific joint.